Now I'm going to do a chi-squared test of independence in the car data. And so one of the things I'm going to do is I'm going to create a new categorical variable. And what I'm going to do is I'm going to divide the cars up into little cars and big cars. Excuse me, vehicles, because some of them are cars and some of them are trucks. And then we're going to see if vehicle type, car versus truck, is independent from whether it's little or big. So first we need to find out what the middle size is for our cars. So we will do frequencies, excuse me. And I'm going to look at weight. For statistics, I will like the median weight. And I don't want to see frequency tables, so we'll hit OK. So the median weight is 3.342. I can even double click in there, copy that value, so I don't have to remember it. Yeah, you could do all sorts of fancy formatting, which we will not do. So now I can create a new variable. So I can do compute variable, target variable, size, and we will say, we'll give a label. So the label is going to be size, category, continue. And the new numeric expression is going to be curb weight is greater than or equal to the weight that we copied. So anything bigger than that, this will evaluate to 1. Anything little than that will evaluate to 0. So we hit OK. Now we can go to our data, and go to the variable view, and we can see our new variable down here. And we don't need decimals, and we don't need to keep, we only need 1 digit to keep track of that, and we're going to have 2 values. So value 0 is going to be, we'll call those smaller, and 1 we'll call larger. Here's another advantage of using numeric codes instead of labels. Smaller comes alphabetically after larger, but 0 will come first when it's ordering the levels because we told it that's a 0. Similarly, if we were giving a report in Japanese or German, we could just change the labels and not have to change the data. So it would be much faster. So that's another reason why it's good to use labels for your labeled numbers for your categorical variables. All right, so we've developed size category. You can see it already figured out it was nominal. So now we can do our chi-square test of goodness of fit. Not goodness of fit. Independence. So remember, our null hypothesis is there's no relationship between the car's type, which you can see there's automobiles or trucks, and the car's size category. So let us run that analysis. So we're going to do analyze, descriptive statistics, crosstabs. That's short for cross tabulation. So I tried it with manufacturer first to see if that would work, but there are too many manufacturers and it didn't make any sense. So we'll get rid of that. We'll go down to size category, rows, go to statistics, and if I hadn't already just tried this with manufacturer, this wouldn't be checked, so I'm going to check this to make sure that we can see them. And now we're ready to go. We'll continue, hit OK, and here is our chi-square test. So we can see that 69 cars appear as automobiles in the smaller category, and only 46 are larger. 8 are in the smaller if they're trucks, and 32 are larger. So there is an excess of automobiles in smaller and trucks in larger. Go fig, right? And that is a highly significant excess. So we could say, if we're going to do a word report, we could paste this in here, and then we could say a vehicle's type was not independent of its size category. Let me do chi squared sub 1 equals equals C1 degree freedom 18.99. 9, P is less than 0.001. And then that gets subscripted. That gets superscripted. And I'm done.